So, like we said, we built the system yesterday with utilities and generators through an auto transfer switch. What I'm going to add now, Jeff, is overcurrent protection devices. So, Adam, my friend, you can see that we're missing. Can you guys see we're missing? What are we missing here? We're missing one major component. Where are the circuit breakers? The main circuit breakers in this. Where are the main circuit breakers in this? Right? So what I'm going to do now, I would like you guys to go add circuit breakers for these. We're going to add circuit breakers for these components. So do me a favor. I would like you guys to extend, do what I'm going to be doing right now. So let's grab this one and extend it slightly down. I want this extended. I know you're going to see why I need, like, make a neck for it here, if that makes sense. Extend it slightly and let me know when you guys are done with this, because I want to do something right in this area. So if you can you guys see what I'm doing? Grabbing it and adjusting it right in here. Something similar to this. Can you give me a thumbs up when you're there? Have enough room in this area. The reason why I'm going to tell you why we're going to have enough room in this area, because we're going to be installing circuit breakers in this area. Joe, did you open yours? Okay. So what I'm going to do now next, when we do coordination, guys, so we did the calculation yesterday. We're going to do overcurrent protection coordination. When you do that one, step number one is you have to put overcurrent protection devices. You have to put overcurrent protection devices, right? And step number two is do the coordination. Coordinate. So these are really as simple as this one. So the first thing I need to do is I need to input an overcurrent protection device. I need to put an overcurrent protection device. Cool? Okay, so if you guys follow up with your friend Chad here, so these are the two steps I'm going to do. Do me a favor. Can you guys see, and again, I didn't go over all this stuff. The software, guys, is very intense. So I'm making you touch the things that you need for this project and next project. So let's go to Darren. Darren, my friend, do you see that little here? What does it say? New low voltage, right? We're using circuit breakers. So we're going to go grab a new low voltage circuit breaker. Right next to it, can you guys see a new fuse? Right next to it, we have a new overload. Right next to it, we have a motor circuit protector, a disconnect, a relay, and a bunch of other things that you can use here. For this particular project, we're only using low voltage circuit breakers. That's it. Because there's high voltage circuit breakers, there's fuses, blah, blah, blah. For this particular, I want to remind you guys, Jeff, we have a 500 amp panel, and 225 amp panel, and 100 amp panel. All these need a circuit breaker. So I need a 100 amp circuit breaker, a 225 amp circuit breaker, and a 500 amp circuit breaker. So let's go start. Click on this, will you? So now I'm holding a circuit breaker in my hand. Everybody's there? You're holding a circuit breaker in your hand. Now I want to, now remember the circuit breaker was ahead of the auto transfer switch. Remember how because it has to be a service entrance rated. So I'm going to go put my circuit breaker right in here. Can you guys see where? Right in this leg. If you have a leg like I did and you make them overlap, can you guys see how it's overlap? And click. Now you have just entered a circuit breaker in this field. If you don't have a leg, switch them to have a leg there. Does that make sense? Switch them to have a leg. So that's where you're going to have. So we're going to stretch that one to have a leg. Okay. The first thing you need to do when you have a circuit breaker is we're going to have double click on the name, and I'm going to go CB circuit breaker, and this is CB. This is going to be main, right? Because it's ahead. Well, this will be CB for the ATS, but this is going to be the CB for the main circuit breaker. So that protect the ATS and the main panel. So I'm going to call it just CP. Let's call it CP ATS because it's ahead of the ATS switch. So I'm going to go. I'm sorry. Okay, let's go one more time. The circuit breaker that you need is that one here, that one, and drop it, attach it to the leg, double click on the name, and name it CB dash. We're gonna call this one because it's ahead of the. I really would like to. I know it's ahead, but I'm gonna call it MP though. Let's just call it MP. You know why MP, guys? Because it's the main circuit breaker for the circuit breaker for the main panel as well as the auto transfer switch.
Did you drop the new LD breaker or did you drop the new
LP, low voltage. Okay, they all look alike. So can you guys see that? You don't drop this. This is new motor control protector. This is what you need. This one is the new low voltage breaker. That's the one I won't drop. Can I have thumbs up when you guys are done naming it? You drop it and you name it. Cool? Okay. Let's drop another one. Grab the same circuit breaker. Now from the generator side, I also need a circuit breaker on the generator side. So I can put my generator side circuit breaker just for organization. I'm going to put it right in here. Do you see where I put my generator side circuit breaker? And I'm going to call this, and move the name like I did, and double click on the name and call it CB for circuit breaker and gen. So I know this is the one that's coming from the gen. This is circuit breaker coming from the gen. Cool. So what I did, I just stretched it. Carrie, my friend, we just opened the riser and we grabbed the circuit breaker and we dropped it. That's all what we did. So if you open your riser, I'll walk you quick through it. When you open your riser, stretch the neck here. And this is a low voltage switch. If you can see that way at the top, new low voltage. We dropped the 2 circuit breakers. That's all what we did. Okay. All right. I want to like, since I'm using capital for the gen, I'm going to go back again and use capital letters. So I'm just to be consistent. Gen. Okay. Okay. When you guys are there, can you give me a thumbs up, please? Cool. Okay. All right. Stretch it. All what you have to do is just click on it. When the name is like this, Jeff, hover over the name and you can move the name. So you might have to be a little bit more creative. Let me see. I know it's hard sometimes when they're. I don't know if you go here. There you go. There's the other one. You just. There you go. Yeah. It takes a few seconds to get used to it. Okay. Cool. Shall we name them? Everybody name them circuit breaker 1, gen, and main. Now I'm going to go down here. I'm going to go down here and I'm going to stretch. Can you guys see these? I'm going to go highlight them like this and I'm going to stretch them slightly. Can you guys see how I highlight them and stretch them a little bit? The reason why I did this, Darren, my friend, because I want to install a circuit breaker right here and a circuit breaker right here, right? Isn't that what we're doing? If you guys remember yesterday when we were looking at the riser in Revit, the circuit breakers for the lighting panel as well as the receptacle panel are located in the main panel because we're using main lugs only. So I can't put my circuit breaker here, right? Everybody understand? I can't put it here. I can't put it here. It has to be way at the top right here, right? Everybody understand why the circuit breakers for the lighting panel and receptacle panel have to be in the main panel? Because that's how we design the system. Gentlemen, when you stretch it, can you give me, I'm going to go, you can highlight them and drag them slightly. You know, you can adjust them. Can I have thumbs up when you adjust it like this, guys? We're going to do the same thing. We're going to install circuit breaker right here. This is the only one, Kerry, that we're going to install. There's a fuse here. All these, we're not using them. In this project, we'll only use one type of circuit breaker. Click on this. I'm going to drop one here and click again and drop one here. So I'm going a little bit faster now. So I have 2 circuit breakers and I'm going to go, gentlemen, double click on the first one. I'm going to name it CP dash, that one going to where? In my case, it's going to lighting panel. CP dash LP, so that will be my LP circuit breaker. And this one is going CP dash RP, in my case, going to the receptacle panel. Gentlemen, you have just installed 2 overcome protection devices for 2 pieces of equipment. 2 overcome protection devices for 2 pieces of equipment. Any comments, guys? Any questions about these overcome protection devices? Does yours start to look like your friend Chad here? Does it start to look like this? Right? We have 4 circuit breakers, 2 mains, and 2 for the 2 panels. Now, who am I going to pick on? Joe, my friend. When you do short circuit coordination, when overcome protection coordination, the only circuit breaker you care about are the mains. That's it. Branch circuits. Not a big deal. Only the mains that we worry about. Only the mains that we worry about. Can I have thumbs up, Chad? We worry about the mains? Cool. So that's what I'm going to do. I have this one. Now to do the coordination though, here's what I would like you guys to do. Now we can go do the coordination between the overcome protection device, the mains, and these 2 circuit breakers easily. Easily. But I need to do one more two more coordination that's vital for this project. So if you guys look at what was the largest motor that you have in this project, the largest single standalone motor. Anybody can tell me what was that? Was it the air handling unit or the chiller? Chiller. Okay. So we're gonna go. Okay. So when you do the over-competition coordination, guys, you're gonna make sure that your circuit breaker does not trip every time you start the chiller. So here's what the rule is. The rule is, if you have typically if you have a horsepower, a motor, 15 horsepower or larger, you do coordination for this motor. Anything less than 15, ignore. Most likely will coordinate. Can I have thumbs up, chat? 15. Some people go down to 10. Some people go up to 20. But 15 horsepower or less, ignore. More than 15 horsepower, do coordination on that. So I want you guys to pick any motor that have 15. Do we have 15 horsepower or larger? Any load 15 horsepower or larger? We have 3 loads 15 horsepower or larger. Can you guys see that? We have the air handling unit, we have condensing unit, and we have future condensing unit. Anything else, the rest of them, guys, is 1 and 2 and 3 horsepower and 4 horsepower and all this little stuff. Okay? So I'm going to use anything just for if the horsepower is more or equal to 15, coordinate. For the coordinate. Now, is it wrong to coordinate 10 horsepower? No. We're just going to cut it at 15 this time. Now, Jeff, the only 3 loads that are more than 15 are 3 loads. Number 1, in my case, is air handling unit. This is 15 horsepower. Number 2, as condensing unit number 1. It's an 80, how many amps is that? That was a big one. 81.6 amps, because that's a chiller. And number 3 that I need to coordinate is condensing unit number 2, which was, what's the amp on that? Thank you, sir. 44.6 amp. I need to model these branch circuits. The reason why these branch circuits are important when it comes to the coordination, because they're big. They can make or break the coordination in your system. Anything lower than this, guys, ignore. Can I have thumbs up, Chad? We understand why we picked these. Okay, so since we picked these, I'm going to go ahead and input these in our calculation now. So I would like you guys to do me a favor. Can you guys see the main panel? Go stretch the main panel. Stretch the main panel. Can you expand the main panel bus? Expand the main panel bus. Did you see how I did that, Adam? You hover over the edge and you stretch it. Cool? Joe, my friend, cool? Okay, now, what I want to do, guys, is I want to create a branch circuit. Let me show you the easiest way of creating a branch circuit. We said yesterday, regardless of your religion or system, belief system, you have to believe in cloning. So what I'm going to do, here's what I'm going to do. Very simple. I'm going to create 3 branch circuits here. 1, 2, 3. When you have a branch circuit, what do you need? Overcomputation device. 1, 2, feeder, 3, load. So what I'm going to do, guys, is I want to, instead of creating it from scratch, which I can, I'm going to go highlight this, only this. Cool? Highlight just that branch. Cool? This will expedite the process for you. Instead, now here's what, Joe, I could have easily brought a circuit breaker, brought a cable, or brought a bus, right? And start from scratch. But I already, yesterday, guys, we worked on the cable, we put wires in this cable, we put voltage, and now we create a circuit breaker. I'm going to highlight these and clone them. Why would I do something like this? Expedite the process fast, instead of creating it from scratch. Okay? Everybody highlight this. Do me a favor, right-click on it. And when you see the word clone, hit clone, and don't go anywhere else. Hit clone. Do you see that branch that's set right next to it? Now you're going to go be very, very creative in picking it up. Can you guys see? Very creative in picking it up and moving it. Oops. Now, if you did this one, go back, cancel. Go back if you did like what I did. You might have to be a little bit creative, like I said, and dragging it and putting it right in this area here. When you guys are there, give me thumbs up. Cool? Okay, now, is it still blue like this? Is yours still blue?
Were we copying the panels too, or just?
No, just we copied, we don't want the panel, because it's not a panel. It's just we're copying a branch circuit, guys. We're going to add a motor to that bus. You're going to see in a second, we're going to add a motor. Okay, if it's still highlighted like this, by the way, gray means it's not connected to the system. It's not going to get juice. So if you pick it up like this and then drag it, oops, mine is so sensitive here. Pick it up, and when you see that across, drag it and make it touch the bus and drag it slightly down. Now, this branch circuit is connected to the panel. When you guys are done, give me a thumbs up, please. Okay? All right. You might have to maneuver it slightly, gentlemen. Darren, you guys good? Okay. Jimmy? Okay, now, I want to remind you guys, this is a circuit breaker protecting a cable, and at the end of it, I'm going to go put a motor. What's this motor? This motor is going to be my chiller. So let's go grab a motor. Can you guys see these loads? Everybody can see that symbol here. Let me just, before you click on it, let me just explain this. You're going to have L for load. Ignore this for the time being. This one is induction motor. This is synchronous motor. Adam, 99% of your time is going to be induction motor. Every time you have a machine, you're dealing with the induction motor. Okay? So do me a favor, click on that baby, and you're holding a motor inside your with your hand. And can you guys see it? And I want you to attach it directly to the bottom of this. Okay? And when it's attached, you can tell it's attached and zoom out. And it should look something like this. When you guys are done, give me a thumbs up, please. Okay. Now let's go to the motor, double click on it. And this is going to be my air handling unit. Do I have two or one? Only one. So call it air handling unit. Now I'm going to go to the bus right above it. Air handling unit 1. I'm going to go to the bus, guys, right above it. And I'm going to click on this. I'm going to call this one air handling unit. B air handling unit. Because that's B air handling unit. Bus for the air handling unit. I'm going to go to the cable, Jeff. Click on the cable above it, and I'm going to call, what do you think I'm going to call this one? Cable air handling unit, because now it's feeding the air handling unit. I'm going to go to the circuit breaker right above it, guys, and I'm going to name this one the same thing. I'm going to call it air handling unit, right? When yours look like mine, please give me a thumbs up, will you? So you have, everything is named after the air handling unit. Does it make sense? Because we're feeding an air handling unit. The cable have to be named after it. The overcap protection device as well as the bus. Okay? Cool? Everybody's okay with this? Air handling unit? Okay. When you're done, Kerry, are you done? Okay. Anybody else is still working? Okay. So now I would like you guys to go to the motor itself. Joe, my friend, go into the motor and double click on it. Double click on the motor. I double clicked on the icon of a motor. Can you guys see this stuff here? Can you see this? This window. Everybody opening that window. Let me see. So this is where you can put the horsepower of your motor. You can go ahead and put the horsepower, or you can go to the library. And you can pick an NEMA size and all this stuff. I'm going to spare you at this time. I'm going to spare you going to the library for it, guys. I'm just going to go put 15 horsepower here. Can you guys see the 15 horsepower here, everybody? I just opened it and I put 15 horsepower here. That's all what I did. And close it. I put 15 horsepower. The voltage is 2.8, right? Is yours show 2.8? Yep. 2.8 three-phase. The only thing I did, guys, is I just put 15 horsepower, 15, right? And exit out of it. One more time. If you click on the air handling unit, you're going to put 15 horsepower and exit out of it. Okay, cool. So I put 15 horsepower. Now, Jeff, can you please tell me what's the size of the conductor that you guys use for this? Do you have your size of the conductor handy? Now, okay, did you guys use number 4? Anybody use number different? Okay, now do me a favor. Go click on the cable. And do you remember we are using number 2 right now? When you click on the cable, go change this one into number 4. And we're still using how many feet? Now remember, the air handling unit was out, right? It was locating, no, it was inside inside the room. So we're using EMT conduit, if the same EMT. So 20 feet, let's give it 30 feet because it's slightly more. Put 30 feet for that boy. Give it 30 feet and exit because it's right next to the panel. And exit out of that. Okay, so what I did, guys, I used number 4 conductor in this cable and 15 horsepower for this air handling unit. Any comments, any questions? I'm sorry, I'm done for this branch circuit. I'm done for this branch circuit. I'm done for this branch circuit.
Do we have to change the conduit or anything like that?
Remember that I copied, good point. Remember, I copied this one, guys. So when you copied this cable, that cable was EMT conduit, right? So I don't have to worry about that one. All I have to worry about is just sizing the cable. Remember how cloning becomes really cool? It saves you time there and going sizing, right, finding the right size, right type of conductors.
You have the size of the circuit breakers?
We're coming in a second. Hold your horses. We're coming to sizing the circuit breakers. 1 second. Yeah. 1 second. Okay, I need thumbs up when you guys are done with this. Okay, cool. Let's go. I'm gonna go clone. I'm gonna go clone. Now remember, I need a chiller. I still need a chiller. 2 chillers. I still need 2 chillers. So for my chiller, I'm gonna stretch my imagination and use the same thing, motors. So do me a favor, look what I'm gonna do. I'm gonna highlight the whole deal here. Highlight it. I'm gonna clone the air handling unit, rename it, rename the air handling unit, clone it, rename the air handling unit as chiller 1 and then chiller 2. That's the easiest way of doing that one. So everybody highlight this. Let's go clone. When you clone, be careful because it makes I'm cloning it. If it's, don't click anywhere. You guess, is it cloned and still blue? Okay, don't click anywhere. Go hover right over it, right over it. When you see the cross, left click and hold and drag. And off it goes. Here's an identical copy of the air handling unit. Identical copy of the air handling unit. Carrie, this is expedite the process. Instead of doing it, guys, every load at a time, it expedite the process. How that's going to work fast. There's no need to reinvent the wheel, huh? Close this one. Okay. Can I have thumbs up when you guys are done with this process? I want to just go adjust it. Look what I do. I go bring it down slightly just to make it look visually. And we can talk about visual stuff. I'm just to make it line up. I pulled it down slightly. Okay. When you're done with this project, with this component, let me know what the next step. Okay, rename. So let's go. First of all, let's rename. I'm going to go click on the name itself. Double click on this name. This is going to be chiller CU-1, chiller number 1. The bus is going to be same thing. CU-1. And oops, don't forget the dash. Let me show you an easier way, guys. If you highlight like this, everybody can see that. If you highlight it, you can actually copy it. And then come over here and highlight this and just paste it instead of typing. Can you guys see I paste the name right away? These are kind of tricky, going fast in the system. You can come here and you can just highlight what you don't want and paste it. Did you guys see what I did? You can copy the text and paste it. I have a branch circuit for my chiller, gentlemen. Okay, oops, I forgot my bus here. I need my bus to go right into here. Bam. Okay. When you guys are done, is it wrong?
No.
Okay, cool. We have chiller 1. So guess what we're gonna do now? I need to go size the chiller though. So double click on the chiller, will you? The chiller itself. Now the chiller is given in amps, right? So I have only kVA. Now this is where, Jeff, when I told you guys in your mechanical schedule, if it doesn't have a horsepower, what did we say it's going to have? kVA. So can you do me a favor? Go convert this one into kVA, change this to kVA. And Jeff, could you please tell me what was the kVA for the chiller? 17. Everybody got that one? 17 for the chiller. How do you find the kVA from the amps? Multiply the amps by the voltage by 1.73, divide by 1,000. So 17, because they are given in 208. Are you looking at the right one?
Yeah, the second one I got 16.
Okay, then 29, was it 29? Okay, 29, yours is 29, guys? Okay, 29 it is. Okay, you're looking probably at chiller number 1. Okay, thank you, 29. And exit out of this. So we put 29, we exit out of it. Thumbs up when you guys are done with this. Cool. Okay, next, Darren, what's the chiller number 2 size? 16 kV. I'm gonna go, now when you're done here, the last step is I'm gonna go clone. We said yesterday, regardless of your belief system, you have to believe in cloning. I'm gonna go clone this branch. Jeff, can you see what I'm doing here? Kerry, I highlighted this, right click on it, clone it. When you clone it, guys, if you're looking at a blue, when it's blue, it's the best way to grab it, attach it to the bus, and drag it down to adjust it. Ran out of room at the end of the bus, what do you do? Adam, look at that. Ran out of room, what do? You extend your bus slightly. And I have cloned my chiller. Okay? It changed it to 2, so you don't have to rename it. That's the nice thing is, it's already renamed for you. Now, Aaron, you have just discovered how to expedite the process of using the software. If you have 15 motors and they're all called M1, M2, MT, M3, take the first one, fill the info, copy it 15 times. It will rename them for you, the buses, the cables, and all what you have to do then is just go adjust the horsepower. So do me a favor. I need to go to the chiller number 2, and I'm going to put 16. Remember that we talked about 16, about kVA for that one. Make sure it's kVA, it's 16 kVA. So everybody adjust the size of chiller number 2 to 16. 16. Now, remember, we didn't size the cable though. So let's go, what did we say cable number, chiller number 1 cable was number 4, right? So Aaron, can you give me chiller number 2 cable, please? Click on the cable. What was the size of that baby? Anybody else? How did you guys size it? How much? 6, number 6. Any second? The chiller number 2. Future chiller. Did you guys get? Number 6? Okay. Number 6. Cool. Number 6 and close it. So my conductors are number 6. Did you under the cable? That was under the cable.
Yeah, did you click on cable?
Yep. I clicked in cable 2 and I sized it number 6. Okay? Are you sure guys number 6 here? 1 second. It was 40, what is it? 44.6 times 1.25 equal, and I need the wires wire size number 6. Am I a doubting Thomas or what? Am I a doubting Thomas or what? Wow. Okay, length. The length for this one, guys, the chillers are outside. So let's give him another 10 feet, will you? So let's make it 40. Typically, you have to kind of 40. And the chiller number 1, 2 is outside, remember? So let's make him another 42. The 2 chillers length, the cables, give him 40, will you? 40 feet. Because they're outside, right? They were outside the building. And right behind the mechanical room. Okay, I need thumbs up when everybody sizes the cables, the size of the chiller, the size of their handling unit, as well as their cable. They're all both 40 feet, yep. Both 40 feet. Now, here's the tricky one. Now, here's the tricky one. When you're done, guys, please give me a thumbs up so I can move it to the next step. Done, done. Kerry, are you guys done? Yep. Okay. Now, do you guys remember what we did yesterday for the schedule? Do you see the schedule here? Did you put the chiller inside your schedule yesterday? The chiller. inside the schedule here? If you did, you duplicate the load. So here's what we're going to do. I want you guys to go open this schedule, the schedule for the main panel, and schedule for the main panel. Can you guys see your schedule for the main panel? Open the schedule for the main panel. Do me one single favor. If you put your air handling unit, I put my air handling unit right in here. As a load, remove it, and grab the air handling unit that you did, that says cable air handling unit, put yourself at the right circuit, and connect to circuit. Did you guys see what I did? Remove what you did in the schedule and add the one that says cable in it. Why? Because yesterday we didn't have them tied to the bus. Today we do. So I added my air handling unit. My chiller, the same thing, guys. I'm going to put it right here, connect the chiller, and I'm going to put the same thing. I'm going to put myself here, and chiller number 2. I put chiller number 1, chiller number 2, and connect. Okay? I put my chillers. You ran out of room. Circuits. You can click on an empty spot. You click on an empty spot like here, and then I'm in my case I'm going to put my panels, guys. I didn't connect my panels. It looks like my panels have been not connected. Yours guys probably connected. I'm going to connect my panels, connect my panel, and connect also my panel here. Okay, so when you're done with this schedule, the only thing that should be left in this window here is cable MP. Okay, do me a favor. You guys, if you put the chiller yesterday here, remove the chiller before you drop it. Did you guys hear me? If you did it, remove it first before you drop it. So when you're done, the only thing that should be left in this window is the cable that's coming to the panel, which we don't, it's not a load, it's just a feeder. If you leave the chiller and you did what I just asked you to do here, you duplicate your load. You duplicate your load. You don't want to do that. So do me a favor. I want you guys to, Jamie, to tell me that you removed the chiller and installed the new branch that we did. Everybody did that? Yes? No? Okay. Now all my chiller, and everybody should, all your panels should be listed right here. When you guys, if you didn't do it, when you print your friend Chad a schedule, it will show double in the schedule, and you lost your 10 points out of 10 in the test and on the assignment. Not like it's scary or anything, but they will show up as double on the schedule. We're going to see, we're going to run schedule out of this. So please do that. Okay, so we did that. If you need help, I can help you. Joe, my friend, did it work? Okay. So when you're done here, exit out of it. The lower exit. Do me a favor, save. Can you guys still save? So we did a substantial amount of work. Let's save it. Okay, so now we are ready. We're ready to do coordination. Now remember, we adjust our system. I'm going to go run calculation one more time. Before we do that, can you guys go to run? Everybody can go run. Run balance study. Run balance study. Does your balance study show load calculation and short circuit, right? And run again. Do you have any errors? If you don't have any errors, you follow directions. Close it. What I did, Aaron, my friend, what I did is I updated my short circuit calculation. Every time you add to the system, Jeff, every time you add to the system, you have to update your short circuit calculation. Any comments, any questions? Any comments, any questions? Okay. So let's, so everybody's good at this time? Now let's go run one more calculation before we do the coordination. Arc flash. Arc flash is a big deal, guys, in the industry. Every electrical contractor, every electrical engineering firm that you work for, they have to provide an arc flash analysis. This will provide you an arc flash analysis. When you're done with this, everybody's done, cool, cool, cool. Let's go to run. Can you guys go run? Everybody run. Arc flash. Can you guys see the arc flash evaluation? Run arc flash evaluation. When you go there, here's what you're faced with. Can you guys make sure the unit is English? not metric. Everybody can see that. You can have so many boundaries. I want to emphasize one little thing. Can you guys see this? We're using, oops, what I like. We're using NFPA 70E 2012 Annex D7 for our calculation. There are so many methods of doing arc flash calculation, acceptable method by OSHA. OSHA enforces arc flash, right? And safety. All these 1, 2, 3, 4 are acceptable methods, arc flash calculation method. I don't want to get you into the details, so we're going to take the default. We're going to use NFPA 70E 2012 Annex D based on IEEE 1584 formula. They have an IEEE 1584 formula. That's what we're using. Default. Cool. Next, can you guys change it to English? Everybody change it to English. And feet. Did you change this one to feet right here instead of inches? The distance and the arc flash boundary. Thumbs up, everybody. Cool. Okay, now let's go to okay it. Gentlemen, you're looking at the arc flash calculation. Now, arc flash calculation, if you give this one to any customer, guys, you're going to get to, so this is the maximum and all this good stuff. The only important thing I'm going to show you is, can you guys see what it says customer label right here? Click on customer label. Does that look familiar to you? Does that look familiar to you? That's what you put on the panel right here. Okay, here's the label that you send to a printing company as a PDF file, and they print it on a nice durable material, and you stick it down to your panel. Now this one, guys, is for which panel though? This is for this is for bus AHU. This is for the air handling unit. Now, what if I want, so this is for my air handling unit. If you click here, you can look at all of them. Let's go to the main panel. Can you guys see? Right click here and go to B-MC, the main panel. What does it say? Dangerous. You cannot work on this piece of equipment. So when you go here, it gives you arc flash boundary hazard is 17 feet. And then dangerous, there is no PPE to work on this piece of equipment. The gloves that you need to use when you're working energized is 00. Avoid contact for restricted and prohibited approach. 70E, gentlemen, and OSHA require you guys, when you work on energized equipment, to do a lot of things. One of them is work permit, hot work permit, or energized work permit. You have to put the proper PPE when you're working on these, and you have to adhere to the rules of restricted, prohibited, and limited approach, as well as arc flash boundary. Long story short, we will talk more about this one in the spring, but that's what this label is going to get you. Cool. Now you can see it's dangerous. Anybody can tell me why it's that dangerous? Because we don't have the overcome protection device yet. So long story short, later on, guys, you're going to do preview here for your friend Chad, and you can click on all these and export them as a PDF file. Export them, not now, export them as PDF file and print them for your friend Chad. All these buses. The three that we care about mostly, well, actually we care about all of them because they have controllers for the air handling unit and so forth. So let's look at another one. Let's look at the lighting panel. Can you guys go look at the lighting panel? That's BLP. Okay, here's my lighting panel. Same thing, dangerous, don't work on it. A receptacle panel. Receptacle panel says level 4, that's category 4. Arc rated shirts and pants and overalls, as well as arc rated shield, flash suit. 2.8, gloves are 00. Limited approach is 3 feet 6 inches. Avoid contact for restricted and prohibited. Do not touch. It might sound like a Greek to some of you guys, but that's a major thing that they do right now in all the panels, but required by OSHA. So electrical contractors pay tons of money to get these labels done. When you, Darren, my friend, when you go to Parson, you say now, after 2 projects, not now, I know how to calculate arc flash analysis, right? That's what the whole idea is, know how to arc flash analysis. Now, I'm going to leave this, close out of it, we'll come back to it, close out of this too, and gentlemen, you have ran arc flash analysis, short circuit analysis, load flow analysis like we did yesterday. The last thing I would like to do is go to the coordination. Before I do the coordination, because I need your full undivided attention, I'm going to give you guys 5 minutes. Stretch, do whatever you want to do. and then I'm going to hit it with the arc flash with the coordination. We're going to do one more component on it, the coordination, and then I'll show you how to print, and we're done out of this software. We will do this software again, guys, in the spring for the industrial project. With it. This is 500 amp. In the commercial project, industrial project, going to be 4,000 amp, 480. So a bigger project, bigger calculation. The concept is the same. You get it now, you're good for the spring. Cool? Shall we do a 5 minutes? Thank you. Give me 1 second here. Let me close my team, please. Kerry will be here in a second. Okay, so the next step that I would like to do, I would like to put some actual circuit breakers and do the coordination. That's the last step. So your riser is ready to go to accept the circuit breakers. So do me a favor. I want to remind you that Adam, your circuit breaker, the main circuit breaker was 500 amp. So I'm going to go zoom a little bit into the circuit breaker. By the way, you probably have discovered by now the zoom, all is here, and zoom in and out. Everybody assume that you got these by now. Okay, so zoom all and go into skip here and go into the circuit breaker right in here, the main. Everybody at the main, and I would like to click on the main, double click on the main circuit breaker. I need to go find an actual main circuit breaker. Do this. Everybody's there? Can you guys look at this one here, right? Okay, go to the library. When you go to the library, you are faced with a huge library, overcurrent protection device library. When you guys are at this level, can you give me a thumbs up? Everybody's there? You see? Okay, one more time. Close this. You go to the main. Here's my main. Double click on the symbol itself. It opened the component editor for you. When you go to the component editor, the only thing I would like you to go is library. Do you see the library? Click on the library, and you're faced with this humongous library that you need to pick from. Every circuit breaker that we use in the industry, is here. If you're not in this library, you don't exist. Okay? So could you please go to the thermal magnetic? So there are static, ground fault, power circuit breaker, and thermomagnetic circuit breaker. For this type of a project, for this small size of an amp, we're using thermomagnetic. You guys are familiar with the thermomagnetic circuit breakers. There are electronic circuit breaker and thermomagnetic circuit breakers. For a smaller project like this, 99% of the time you're using thermomagnetic. Can I have thermomagnetic up and running? Cool. Okay, now when it comes to thermomagnetic, you have all those manufacturers. Can you guys see that? You have ABB, Allen Bradley. You have Cutler Hammer, Challenger. Let's go to something familiar with Square D. Can you guys go all the way down to Square D? Click on Square D. These are all the circuit breakers that you can find that Square D can give you. Square D. Everybody went to Square D. We decided, now how would you do that? How do you know? As a contractor, Aaron, my friend, you have no idea which product you're going to be using, right? So what we do, guys, at the beginning, we use one manufacturer product, and when we get the actual product, when the project is bid, and we know that Square D is going to be doing this, providing the gear for us, then we go back and readjust our calculation exactly based on Square D product. Okay? Everybody knows how to do Square D? Thermomagnetic Square D. One more time. Okay. So let's go here one more time and click. Here's my circuit breaker, any circuit breaker, but I'm going to go to the main. Double click on this. Go to the library. When you go to the library, you're faced with this huge library. Go to the thermomagnetic. Can you guys see thermomagnetic? Go to here and all the way to Square D. You can have any manufacturer, but I'm going to use Square D. Okay, so that's all the products for Square D. All the circuit breaker that Square D can do for this system. Now, if you're overwhelmed, welcome to the club. If you're not overwhelmed, it's you don't know what's going on. Here's which circuit breaker am I going to be using, Chad? You're going to use a circuit breaker that match your short circuit. So what I would like you guys to look at I want you to look at this. This is Square D. It's the type is A, this can get me from 70 to 225. Is this enough for my circuit breaker though? No, I need 500. So look for something that can get you 500. Look for a circuit breaker that can get you 400. I'll see 450 to 600. Let's just strictly look at the amps now. This is the mean. I need 500. I need the only one right now. There's many options, but I'm going to be using guys LC 300 to 600 amp. Cool. This is 600 volt. Can you guys see the voltages here? Meaning the highest voltage that you can put is 600. Let's just, for the sake of the argument, stick with LC, right? Double click on LC and exit out of this library. Gentlemen, you're faced with this. Everybody's, can you guys see? We picked that. Okay, now here's my option. We picked from the library a family. These are like families. Now we're going to see. Are you there?
Or you double click on it,
Did it?
it won't just close out, it'll show.
Oh, close out of it? Okay, close out of it. Everybody's showing it? Yep. Okay. Now when you show it, you're going to come right here. And the first thing you need to do is, what's my voltage? My voltage is 208. So I need something closer to 208. My options are 200, 240. I look at only the 240 options. Okay, so 240 options, 100 kW, 600 volt. I need 500 amp. That's the only option that give me 500 amp, right? Everybody can see that. 240 LC 600. It might be not the best option, but so this is just for the sake of the argument. Let's use this. So
There's one that's
does it say? Okay, let's go. Right, thank you. That's 500. Yep. Okay, so here's my 500. Cool. I got my 500, 240 LC 500. The interrupting rating of this circuit breaker is huge, guys. So that's a drawback, but let's just ignore that for the time being. Okay, do me a favor. Grab the short circuit. Can you guys see the trip? Every circuit breaker have a trip unit that you can buy. The trip unit is an electronic device that you stick in the face of the circuit breaker. So click here and pick 500. Everybody pick that 500? Okay, so that's the only thing I would like you guys to do for the time being. Pick 240 LC 500, 1000 kilo amp interrupting rating with a trip of 500. Thumbs up, Chad? Okay, exit out of this boy. Now, what I need to do, guys, this is the main. On the generator side, the same size. So I'm going to go right-click on the main. See how highlighted? Right-click on it, highlight it, right-click. You remember the copy data? Copy data, click on the generator circuit breaker, right-click on it, and paste data. So what I did, I copied the type of the circuit breaker that I put on the main. I put it on the generator. Piece of cake. So can you guys go click on the generator circuit breaker? Go to go to settings. Do you see the same stuff that we just inputted? If you did not, then this means you did not copy it. Yes? Cool? Okay. Now, as long as we're on it, Kerry, my friend, here's your thermal curve. Here's the instantaneous. This is one of the dumbest circuit breaker you can buy. It only adjusts the instantaneous and the thermal. It's not electronic. We can adjust everything. Next project, we're going to be using very adaptable, very adjustable electronic circuit breakers. For this project, we're using because the project amp is small, it's not worth it to buy electronic circuit breakers for these. So that's what we're using. Okay, close out of this particular one. Now, I want you to tell me, Chad, we already have two circuit breakers for the main and main and generator are there. Everybody main gen there? Okay. Now let's go to the lighting panel. Everybody can see where the lighting panel circuit breaker. Double click on the lighting panel circuit breaker. Everybody's there. So I need to populate all these circuit breaker with data. Lighting panel, go to the library. Now remember the lighting panel, Jeff, same thing. Go to thermal, go to square D because we decided to go to square D. And now I'm looking here's the challenge. I need to use a different circuit breaker there. Why? Because it's 225. So let's look at 225. I can tell you there's one I thought that was really 225. There you go. Look at this. Can you guys see key? Okay, can you see that one here? 600. Actually, this one can get us there right here. Maybe no, this one. Let's use this one. Now, which one to use depends really on the circuit breaker, the interrupting rating of the circuit breaker. I decided to use KA. KA can get me from 70 to 225 amp. Now, Jeff, would 70 to 225 amp cover all the panels and the chillers, right? All the branch circuit that we have, guys, are less than 250. So if I have a circuit breaker that can cover up to 250, I'm covered for all my branch circuits, right? That's why I picked up this one. Everybody picked up this one? Okay. So, well, maybe, I don't know. Let's, maybe that's an expensive for 600. Well, let's just use it. KA. Everybody got KA? Okay, double click on it. Exit out of it. Okay, now you're gonna go here. Now this is a lighting panel, Jeff. I need, what's the size of the lighting panel? It's, what's the amp of that baby? 225. So my options are, here's 250. That's the only option that I have. Pick up the 250. Everybody pick up 250. 250. Click on 225 here. Can you guys see how I picked first? 240 KA, 250, 42 interrupting rating, and 225. That's the best the best fit for your application. The best fit for application. Thumbs up when you guys are there. Okay. So that's why did I pick this one, guys? Because it gives me from 70 to 250. All my branch circuits are within this range. Darren, if you're overwhelmed with circuit breaker, you will be. Because you're going to be dealing with different manufacturer, guys. For the time being, take what chat tells you. When you go start doing the calculation, you're going to contact Square D rep and say which circuit type is best for this type of panel, which is 100 amp panel. They'll be more than happy to tell you it's KA or a QP. You know what I mean? So this is a learning process, guys. For the time being, remember, there's the only decisive factor would be the voltage, the full load amp, and the interrupting rating, right? I think this is a good application because our interrupting rating was 22 when I studied the short circuit. Okay, if you guys did it this way, exit out of it, please. Now, go click on the same circuit breaker, right click on it, and copy data. Copy data. Everybody copy the data. And highlight, look what I'm going to do. Box in all your circuit breakers here, box them in, and right click on the top of them and paste the data in all these circuit breakers. So by one click, I copied the data for this circuit breaker into all the other circuit breakers. Why? Remember, the rest of the circuit breakers are exactly almost the same type, within the same range, 70 to 225. I can use the same family. I don't have to go to the library again, and I can just adjust the overcome protection device. Done. Did you guys see what I did? Pick this one, right click on it, copy data, and box in all these, paste the data on them. Now check. Let's go to the receptacle panel. Double click on the receptacle panel. Go to settings. Can you guys see when you click here, it tells you what the family is, Square D, KA to 70 to 225, all the information here. Then, if you go to the settings, it will tell you this circuit breaker is set at 225. Now remember, the lighting panel carry was what, 100 amp. So I'm going to go right here and pick 100. Okay, let me see if I can get 100 amp here. Do I have, maybe I can go a little bit lower here. Do I have 100 amp? Here's 100 amp. Let me see, right in here. Perfect. Can you guys see that one? Right here. It's KA 240, 100 amp. That's perfect for my application. And then I pick 100 amp. This is the one that you need. You go 240 KA, 100 amp, 42 interrupting rating, and make sure you change the trip into 100 amp, and we're set to go. Cool? Thumbs up when you guys are there for the receptacle panel. Joe? Okay? Everybody knows that you guys are going to work. Everybody's going to work individual on that project, right? Okay? Huh?
Figuring out exactly what we need.
Yeah. Yeah. I'm sorry, what did you say that?
Are you trying to say we need all research to find out what exactly?
Yes. For this project, I'm giving you guys these numbers. Real project, not really research. You just need to talk to Jerry Stanson, who came here. Remember that guy? he will be more than happy to lead you to the right type of circuit breaker for square D. You're using color hammer, you're going to talk to Todd Christensen, the guy who came here. I am using color hammer product. Can you lead me to the best circuit breaker for this 100 amp panel? He'll be more than happy to lead you through it. And with experience, guys, you start picking on all these type of circuit breakers. Okay, everybody adjusted this one. Exit out of this. Let's go to the, now we're going to go to the air handling unit. Now, I need somebody, double click on the air handling unit. Darren, what size did you guys put for the air handling unit? Was it 125? 125. Okay, so I'm looking for 125. So if you guys click here, I have 100. Let's see what my options are. I have 100 or 150. So I start with 150. Then from right in here, I have 125. Did you see what I did? I grabbed 150 at the top and I adjusted it to 125. That's tweaking it right in the front of it. I made this circuit breaker adjustable to 125. Everybody get that? That's my circuit breaker for the Jimmy. Cool. Okay, now I'm going to go to the chiller. Let's go to the chiller number 1. Jeff, what was yours for? Double click on chiller number 1. What was your size for chiller? 175? Was it 175? What's how much? 110. 110. Thank you. So let's go the same, almost the same circuit breaker is going to be 240, 150, 42, 110. Right here. 110. Everybody get that? Okay, 110. Close that one. So for the CU, it's going to be 110. We use, did I go too fast? Let's go back here. You pick, oops, go to the settings, pick the, from here, I need 110. So I can't use 100 because it's, I need to use higher and then adjust it. Can you guys see that? You use higher, then adjust it. So that's why I used 150. I use 150. Close out of it. Let's go to the last chiller, guys, and we're done. Double click on the last chiller, same circuit breaker. What was the last chiller? Over 60. Okay, now this guy, I'm going to go all the way to 100. And I have, okay, do I have 60? I'm stuck with 70. It is what it is.
You can change it to a different breaker.
Well, in real life, yes. You would go back and change it to a circuit breaker that can give you 60. So, and we can go, guys. We can, because this, the family that we picked was 70 to 225. Let's just ignore that 10 amps for the time being, just for the sake of the time. But in real life, you can go find yourself a circuit breaker that can find it. So 10 amps, we're not going to lose each other's over 10 amps. And off it goes. I have populated all my circuit breakers. All my circuit breakers have been populated. We're ready to do coordination. Ready to do coordination. Double click on it. The last one. I went to settings and I picked the 70. Yep. Now, like my friend Jeffy said, can I, Chad, go back and find a different type circuit breaker that can give me 60? Absolutely. Absolutely. Now remember, guys, when you submit this as an engineering firm or the electrical contractor, you're liable. So if you're comfortable with this 70, I can go override the code and make it 70, Jeff. Because I'm the designer. I can prove that safe enough. Okay? Let's do the coordination, gentlemen. Okay, let's do a coordination. Here's the coordination curve that I would like you guys first to do. If you follow up with your friend Chad, pick the main. Can you guys pick the main? Everybody pick the main. Hold the control button. Hold the control button and pick the lighting panel circuit breaker and the receptacle panel circuit breaker. Coordinations, guys, is all about overcome protection device. We coordinate overcome protection device. So I selected the 3. Everybody selected these 3? Cool. We're doing coordination. When you select these 3, do you see that little icon here where it says TCC, time, current, curve? Can you guys see that? Click on it. You are faced with a new curve. You need to create a new curve for coordination. Okay, let's call this one. I'm going to call it, this is going to be main panel, MP, comma, LP, and RP, right? So this is coordinating MP with LP circuit breakers and RP circuit breakers. We're coordinating the main circuit breakers of the LP and LP and RP with the main panel circuit breaker. Okay, let's go one more time. highlight them. You click on that one here. Okay. And then you call them, I'm going to call it MP, comma, LP, and RP. You're going to give it a unique name, guys. You have to give it a unique name, because when you start doing reports, and if you give it curve 1, good luck, know what curve 1 is. So I know that I'm coordinating the lighting panel with receptacle panel with the main panel. Meaning, if I have a short circuit in the main panel, in the receptacle panel, the main circuit breaker for the receptacle panel should trip first. That's what I'm doing. Thumbs up, Chad, when you're there. Okay, this is new, so click new. Now you're faced with this. Oh, okay. Did you guys see anything? No? Okay. All right. So let's go ahead. Let's go ahead and run calculation. I think we haven't run short circuit calculation since we did them. Do me a favor, go back, click out of it, and run. Do me a favor, go run calculation one more time. Run calculation, load flow short circuit. Run your calculation one more time. Run your short circuit calculation one more time. Do you guys run it? You can run it right directly from here. Click on it and run calculation one more time. Cool? And let's do the process. I thought we could populate this son of a banana. Okay. So let's pick the main and pick this and pick that. Did you guys pick it? And let's go to, oh, I'm sorry. I think I lied to you. I lied to you, gentlemen. You need this one, that one. That's why. Can you guys see this? Go to Tcc Drawing. That's how we create a Tcc Drawing right in here. They just look alike and confuse me. Can you guys see the icon here? After you highlight them, everybody highlighted them? When you highlighted them, go to this. Okay, I already have my curve. Do you guys have a curve already created? Okay, click on it and open it. Click on it and open it. There you go. So yeah, say yes, and you are, and click on devices. Can you guys see these? Everybody can see these curves? Everybody can see these curves? Yes, no? Okay. Yep. All right. So I want to create by, if you guys look at the first curve is the main panel, the lighting panel, and the receptacle panel. Now, can you guys see, are they touching each other and where? The only time that these are not going to coordinate is right in here at the instantaneous. So there is no coordination here, right? This area here is no man's land, and this circuit breaker will, any one of them will trip right here. Everywhere else, they're not touching. This means they're coordinating. Now, this is as good as you can get in a thermomagnetic circuit breakers. Almost as good as you can get in a thermomagnetic circuit breaker. Gentlemen, let me show you how we then. So here's my curves. Now, can you guys go to settings? Click on settings here, right here. Can you guys see settings? And let me go to the main. Here's my main. I'm going to go adjust a couple of things. Click on main, it becomes black, right? Everybody's clicking on it, it becomes black. Go to settings. Let me show you one. Instantaneous. Let me, right next to the instantaneous, let's go set the instantaneous at high. See what did? What this did? It shifted it all the way. One more time. See how we coordinate? Click here. If you go set your instantaneous at low, this is how it looks like, right? If you set your instantaneous the highest, it shifted it away. So do I have a better coordination here, Jeff? Yep, a lot of better coordination. Here's my problem, guys. Every time you mess with the instantaneous, you expose your panel to more arc flash, arc blast. We're going to ignore that one. So yes, it's better coordination, but now you're exposing the electricians who are working in this area here to a higher arc flash for a longer time. A higher arc flash for a longer time. Who cares if you're wearing the PPE? So so long story short, you're gonna have the heavy medium. What's the heavy medium? So I'm coordinating. If I go here, let's just go to 6, right? Can you see how I'm moving? And by the way, you can do this one also right here. Can you guys see I can adjust it with my hand visually? That's a nice thing about the software. Here's the least. This is the instantaneous, which is the least, which will give me the best protection for the electrician. If you click on this, I can move it all the way up physically to the highest settings. This is the best for coordination, the worst for the electricians who's working on the equipment, meaning it's going to be exposed to a very high arc. Okay, so you can see this is only an instantaneous side that's coordinating. Okay, so do me a favor. Let's do the following. Let's start with first of all. Let's start with the receptacle panel. Oops, receptacle panel. Can you grab the my receptacle panel? Look at this. Click on if you adjust your instantaneous on the receptacle panel this way, move it all the way up. Are you still coordinating with the man? The man, here's the man. The man is red. Are we coordinating with the man? Yes. Are we coordinating with the lighting panel? No. Do we care about coordinating with the lighting panel? Remember, they're not in series. There's two different circuit breakers for two different panels. I care less. So you only care about coordinating RP, the circuit breaker for the receptacle panel, with the main panel. The receptacle for the lighting panel with the main panel, right? Because the lighting panel, receptacle panel guys are not fed from the same circuit breaker. They're two different circuit breakers. Okay, click, but for safety, I'm going to set my instantaneous. Can you guys see how I can adjust the instantaneous here? I'm going to make sure my receptacle panel is set as low at instantaneous. Let's go to click on the lighting panel. My lighting panel, look at the bad design. Here's a bad design. I pushed my lighting panel instantaneous to overlap with my main panel. If you have a short circuit right here.
Yeah, I don't think you understand the speech.
What's the what?
You're saying it's bad.
Okay, take this. If you have a short circuit right here, right at this point, cool? And the short circuit right at this point is going to go up, 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 up. It's going to hit. Is it going to hit two curves at the same time? The way it's showing right now, are they overlapping? This means the main circuit breaker and the lighting circuit breaker are going to trip. That's it. As easy as that.
Whereas if you have a good design, only one will trip.
Yes.
Well, you don't want the main to trip. That's the point.
That's
Before the subject trip.
absolutely. That's it. So guys, we have the main. Here's my main, and here's my two receptacles. This one is my. This one is my main panel. This one receptacle. This is my lighting panel. This is my receptacle panel. Okay. Now, if you have a short circuit carry right in here, which one do you want to trip first? The lighting. Right now, the way I'm showing it right now, it will trip first if the short circuit is here. It will go all the way up now. Oops, yep, it will trip first. If the short circuit is here, yep, it will trip first. This area, if the short circuit is this value, basically. So let's just say values. If the short circuit at this value, at that much they coordinate, that much they coordinate, that much they coordinate. At that much, at this point, they don't coordinate. That's what this means. How do you,
Trip the main before the light.
it will trip the main before the lighting panel, or they trip them simultaneously.
I have a good example.
Yep.
I was at a Cup Foods and I was putting in a timer switch, and I pulled the switch out of the wall, and the hot wire hit the frame of the switch, and it blew the main and took the whole place down.
That's a bad day.
That's bad coordination.
That's a very bad coordination. How do you solve this problem? How do you solve this problem, guys? By everybody can see that. And then the second thing, if I have a short circuit on the receptacle panel, which is right here, the one that's going to trip right now up to is the receptacle panel, right? Right? You don't want the main to trip at all.
You just keep them all at low then. When they're at low, they're fine.
Yeah, well, you can put them at low, and that's what we do. They're fine when they were at low. So then, let me just go back here. So, and let's do the coordination. So now, if I do this, okay, now can you guys see that? Now, am I coordinated fully? Am I coordinated? Drag these all the way as far as you can get them. We don't want to alter this. Here's my 100. Here's my 225. And my main, I'm going to push my main to the side. Okay, now can you guys see that the only time that they don't coordinate, the two curves are right in here. Everybody can see that? The only time the circuit breakers are not going to coordinate, only right at this area. Everywhere else, they're going to coordinate. Who cares? Exactly like you were. If you have a 20 amp circuit breaker, short that 20 amp circuit breaker branch circuit, it will never trip, because that 20 amp circuit breaker short circuit is going to be right in here. And which one, if it's in the lighting panel, which one is going to touch first? The lighting panel, right? If it's the receptacle panel, which one is going to touch first? The receptacle panel. If the receptacle panel did not trip, here's the nice thing. Say the receptacle panel did not trip, then it keeps going up, 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 and until it hits the main, and the main will trip. That's like your second line of defense. The main become your second line of defense, not your first line of defense. Does that make sense? So that's, gentlemen, you are looking at coordination. You have just entered the world of coordination. Can I, before I leave here, very good point, Kerry, can everybody understand that if the curves are not touching, they are fully coordinated. The only time they're not coordinated is right in here, right at this corner here. And you know what this is? This is all hell break loose. All hell break loose. If I'm working in this panel, and I took phase A, phase B, phase C inside the panel, both them together, flip the switch, the main will trip. As well, the main of this panel and the main downstairs will trip. How often that happen? Only probably 1% of the time, if even. Most of your short circuits that you encounter, like you said, Jeff, most of them are covered in this area. This area here, I'm just going to highlight this area. This covers 99.9% of your situation. So you're protected almost 99% of the time. This is 0.1% of the time. 0.1% of the time. So I'm taking a chance. At this 0.1% of the time, I'm taking a chance. But I'm protected up to 99% or 99.9%. Do you guys see that? Everybody can see that? That's what the coordination is.
Well, why would you select anything other than low?
Ah, good point. Well, suppose that there was a 20 amp circuit breaker curve that sits like this. Right? This guy was a 20 amp. I'm not showing it. Are they overlapping here? So that's when you move this one high. Very good point. Very good point. Yes, sir?
Mine's not showing above 1,000.
Yours is not showing. That's the scale. I'll show you this in a second here. I'll show you how to set the scale. You guys can see the scale here is cutting at this value. Let me show you how to scale the curves. Any question about the coordination? Your curves are not touching the minimum amount of touching that you need. So you are done with coordination curve number one. So do me a favor. When I would like you, please, let's go to receptacle panel. Make sure it's set at low. The lighting panel, make sure it's set at low. And the main panel, make sure it's set at high. Okay? Right? That's how we're going to coordinate our system. And we're taking a 1% chance here of tripping. Okay? I'm going to show you how to adjust the scale. Scale this curve. This is just scaling. Can you guys see the voltage and everything else? If you go sitting here, can you guys go sitting? Click on sitting. And TCC sitting. Everybody can see TCC sitting. Add a zero. Add a zero to this side. And I also like to add proportionally a zero to the other side. So I added 1 0 at the top, max and max for both of them. And click OK. Do you see how it shifted the curve inside, give you more room here? Did yours work when you shifted them?
No, literally my lines, the 3 lines are stopping at just above 1K. Not the.
That's short circuit issue. That's your short circuit calculation. That value here, the value that you guys can see right here, is the largest amount of short circuit that you encounter in your system. This value here is set by the largest short circuit inside the panel, inside your panels. Okay, that's your calculation. When we adjust the loads in yours, it shifted it. Okay, actually, maybe we don't want to shift the top. So current access, range. I think if I get that one, I always get them. Okay, so no, not this one. 6 setting. That's how we adjust the settings, guys. Add 0 here. Remove a 0 from here. There you go. So it gives you the you can adjust the X and the Y and the X. But the only thing I would like you to do is just adjust this one where you can see the end. So we're sitting at, I can see my curve here, current in amps. So we're sitting right now, the available short circuit right here, guys, is 10,000 amp. 10,000 amp. Okay, everybody can see that? Okay, so we're fully coordinated. Let's do one more curve. So before you leave here, that's what you're going to print for chat. When I ask you guys to print, all what you have to do is just go hit print, and here you go. You have a print, and you print them colored. Cool? Okay, close out of this. And before you leave here, I need you to run a setting. So if you guys go run, while you're here, run. Do you see where it says a TCC report at the bottom? Everybody can see run TCC report. Run TCC report. It will tell you, do you want to run a report about these curves? Yep, because ultimately, we don't give the, Jeff, you've never probably, they don't give you these curves. They give you a set of settings to adjust in the field, right? We don't give these to the electricians because it's hard to get the data from curves. This is just for us to look and make sure they're coordinating. In the field, what we give the electricians, guys, is a report. So here's a TCC report, hit OK, and just take all the defaults and hit OK. And it says, do you want to save it in with all the project with the same name? Hit yes. And here's how your report looks like. So let's look at the main circuit breaker. The main circuit breaker, the one that I'm going to give to my friend Jeff, it says 500 amp. The thermal, it's a thermal, and the instantaneous have to be set at hot. Can you guys see that? Everybody can see that? Can you see that, everybody? So if you go down here, you can go down here. Here's the report that you give to the electricians. I have my, can you guys see that report? You print, give to the electricians to do the settings. Here's my, the only thing I can set is really the instantaneous. Everything is set. Here's the circuit breaker. Here's the amps. It's thermal. Here's the interrupting rating for each one of these amps. Here's the type. This is the report that we submit for the electricians. Cool? Any comment, any questions? Gentlemen, you're going to print this report for your friend Chad. So how do you print this report? Here's the print here. Can you guys see that? You hit preview right to the top here. You hit preview and you got yourself a report. Cool? Okay, close out of this. Close out of this. Close out of this. And now let's go back and to do one more coordination, will you? One more coordination. Okay, so we coordinated everybody back to the same panel. Back to the same panel. Everybody back to the same panel. Okay, now I'm going to coordinate the chiller. I'm going to coordinate the air handling unit, not the chiller, with the circuit breaker for the air handling unit with the main. So this will allow you, Darren, my friend, to say this circuit breaker will protect the air handling unit, number one. Number two, allow the air handling unit to start. Number three, if you have a short circuit in the air handling unit, you want the main to trip. You want the main to trip. You want that circuit breaker to trip, not the main. Okay, do me a favor. Pick the air handling unit, will you? Everybody pick the air handling unit. Hit control and pick the circuit breaker of the air handling unit. Everybody get that too? Continue to hold control and pick the main. Can you guys see that? I picked the air handling unit, the circuit breaker that protects the air handling unit, and the main. I need to coordinate. What am I, before I go anywhere else, if there is a short circuit right here, guys, if I have a short circuit in the air handling unit, which circuit breaker you want it to trip? This one. If this trips, you didn't do your job, right? That's what I'm trying to prove. So all of them are selected. So let's go coordinate. So hit that curve, coordinate. Now this one, I'm going to call it air handling unit. That's it. Air handling unit. So when I'm looking at it, it's going to be an air handling unit coordination. Everybody get that? And hit new. Gentlemen, you got yourself a new curve for the air handling unit. So let's study this. Let's look at the settings for this. I'm going to go to my main circuit breaker. And here's my settings for the main circuit breaker. Okay? Now here's what I would like you guys to look. I'm going to coordinate them first. So what I would like you to do is click on this and make sure it's sitting at the top. Click on this and arrange them from right to left. From right to left this way. Can you guys see that? First, from right to left, is the main breaker. Second, from right to left, it's going to be your air handling unit circuit breaker. Third is the starting curve for the air handling unit. So what does that mean? What does that mean? What this means, guys, when my motor starts, can you guys see that? Up to 10 seconds, these are seconds. My full load current of my motor is this value. So up to, it allows, can you guys see this area? This area is the starting current for my motor. For 10 seconds, the motor, guys, will start, right? It takes a lot of current to start. So my circuit breaker will allow the motor to start. Can you guys see it's allowing it to start, right? It's not tripping. And then allowing it to start. And then if it doesn't start, if it continues, if it hits here, it will trip. So the goal is the circuit breaker allowing the motor to start. What does that mean? How does it do if it doesn't allow the motor to start? If it cuts right here, look at this. If you move this one all the way to this side, this means every time you start your circuit breaker, your air handling unit, the motor will trip. Bad news. And so that's the first thing that you need to look at. The second thing is, can you guys see these two curves are not touching each other? And the only time they miscoordinate is right in here, which is that 1% of the time. Can you guys see that? So we're only miscoordinating right at 1% of the time. We are almost, and they're fully coordinated as you can get. So that's basically what coordinating these two together. So let me just putz around with the curves, and so these are cool. Click on this curve, guys, and you can't drag this curve to the right. I can drag it to the left. I drag this curve to the left. Very bad news. Very bad news. Why? Because if you drag it to the left, why are you dragging it to the left? By dragging it to the left, you're allowing the short circuit to stay longer and have arc flash. So I need to drag it therein to the right. I mean, drag it to the left this way, as far as I can. As long I'm going to drag it to the left as far as I can, without overlapping with the start current. Without overlapping with the start current. So one more time, look at the start current. Is the start current overlapping with the circuit breaker ahead of it? No. So my motor will start beautiful. It will start beautiful. Can you guys see that? Start beautiful. Then second thing, is my air handling unit circuit breaker overlapping with the main? Meaning if it has short circuit, which one will trip first 99% of the time? This one. So how do I make him not trip, guys? If I look at this, if I grab this, if I grab it and move it all the way down, now I'm moving it from 99% of the time into maybe 95% of the time coordination. So moving it all the way, shifting it, that will allow me to have only 1% of miscoordination. Any comments, any questions? Let's go adjust the curve, will ya? So go settings, TCC, put a 0 here at the top so it can shift shift them down. So I shifted the curves to the left. Any comments, guys? Any questions? Let's go run a report. Run TCC report. Which one? Air handling unit report. Yep. Okay it. Then hit OK and save it, and it will open it for you. Here's what you're gonna see, guys. It will give you information about your motor starting curve, 15 horsepower. Can you guys see that? Power factor, as well as the setting of the circuit breakers, the main breaker settings. That's a report that you give to Mr. Electricians in the field so they can adjust the settings of the circuit breakers. Done with this, exit the lower. Okay, everybody's okay with this? Let's do the last curve and then we're done. So close out of this. Okay, one more curve. I'm going to do these two curves, guys, together. Well, let's do two more curves. I'm going to do them fast, quick here. Click on the main and click on the air handling unit, the chiller one. Click on chiller one and condensing unit. I clicked the main, the circuit breaker that protects the chiller, and the chiller. Same thing. I'm going to go, guys, to TCC. This is going to be CU-1 curve. Curve for CU-1. And I'm going to hit new. Now here's my curves. Here's my curves. I'm going to go look at this. Is really interesting. I'm gonna go set the TCC, just shift it a little bit, put a 0 here, so we can shift the curve. And then, can you guys see now this is a good example of miscoordination. Now, look at this. Can you guys see the circuit breaker here is overlapping with the starting current? Everybody can see that? Did you guys get it? Darren, did you get that?
No,
Should we do it one more time?
ours is good.
Okay.
I put a different size.
Different size? Okay, so it shifted it. Now, but if you're looking at this, can you guys see the circuit breaker, this area here in particular? This one, every time you start your chiller, your circuit breaker will trip based on these settings. You will discover this day one, guys, when you start. So how do you fix the problem, Chad? No problem. You come over here and you adjust the instantaneous. Can you guys see the instantaneous? Click on this curve. Here's my settings. It's sit at low. Instantaneous here is sit at low. Let's go put it high. Can you guys see that? I set it at high. Now they are, there's almost full coordination between the two circuit breakers and the starting curve of the chiller. Now how high? How high is the bad news? Now right now I set it at very high. Now, you know what? Why should I set it very high? The only thing I care about is just not touching this curve. So look what I'm going to do, guys. I'm going to drag it enough just to clear it. Can you guys see at 2? Thank you. Perfect coordination. You drag it enough just to clear the curve. Just to clear the curve. You drag it enough just to clear the curve. Now, what's wrong with putting it high? Putting it high, the maintenance electrician working on the controller, have short circuit. When you have a short arc flash, big arc flash, if it's at high. At 2, smaller arc flash, so you protect the people more. Cool? Same thing, I'm gonna go, guys, run the report, run, Tcc report, same thing, run it, okay it, and here's all, and you say, can you guys see where we save the report? All the reports are saved in the report area, and exit out of it, and go to do the last one, okay? So now the last one, I'm going to take the main, same thing with the air handling unit number 2 and with the circuit breaker for air handling unit number 2. I need to coordinate air handling unit number 2 with the circuit breaker, its circuit breaker, and with the overcam protection device for the equipment. Everybody got that? Let's go to TCC now. 2cc. I'm going to call this is air, this is CU, cooling unit, I'm sorry. CU-2, new, okay it, expand it, here's my settings. Now, can you guys see the miscoordination again? Everybody can see the miscoordination. Is yours miscoordinating like mine? Barely, yep. So here's what I'm going to do. Click on this and drag it slightly at 2 again. Jamie, do you see how it's dragging it to coordinate a little bit? Okay. Do me a favor and click on this. Click this. Click. Can you guys arrange them? Can you guys arrange the main circuit breaker and cooling unit? Are you guys okay there? Yeah. Okay. Okay. So here's you're coordinating your main with the circuit breaker that protect this chiller with the chiller itself. Okay. What's miscoordination? Miscoordination is grab this and make it all the way overlap with the starting curve. Now every time you start your trip. What's bad coordination is dragging this all the way back, allow a bigger gap here, arc flash. What's the best coordination is drag this as close to the curve but not touching it. And that will give you a setting of 2. Okay, so these are coordinated. The only time, Jeff, they're not coordinated is right at the bottom 1% here. Run a report and I exit. Let's go run a TCC report, okay it, run the report, save it, and exit. Okay, so these are all the coordination that we did, guys. All the coordination I did in this. Very easy, very simple, huh? You do coordination for anything 15 horsepower or more. Now, we covered everything 15 horsepower or more. Cool. Now, let's go back and see where are they stored, Chad? What if I need to go retrieve them? Where are they stored? all your curves are stored right here. If you click here, guys, here's all the curves that you were looking at. Say, let's go to the air handling unit, double click on it. Here's your curve for air handling unit, right? One more time, close it, go back. All your curves are stored right here, okay? All your reports that we ran are stored right here. Click on the reports, text reports. Here's all the reports that you guys ran all the time. So if I need a coordination report, let's just see, here's all the reports that you did. Let's go slower a little bit. Okay, let's go. So your curves are all saved here. Your reports are all saved here. So let me just expand that one so show you the reports that we have. Click on text, and all your reports that you ran, if you followed what I told you, are right in here. Let me just walk you guys through the reports. You have an air handling unit report, chiller report. Can you guys see that coordination? Input report, load flow report, short circuit report, and MP, LP, and RP report. These are all the reports that you want. So let's say we want to open these. You guys are going to print these to Chad, put them in your binder. All these reports have to be printed. All the curves have to be printed, as well as the riser. So what do you need to print? When you print, I want you guys to print all these. Oops, I can't do it. All these have to be printed. And then the reports, which is easy when you run them. Then I would like you guys to print this riser. How do you print the riser? Here you go. Print view, adjust the scale, and off it goes. And I want you to print the curves. Here's all these curves, one at a time. Click on them and print them. One at a time, click on them and print them. Okay? One at a time, click on them and print them. Okay, so that will close the last component, guys, of this project, which is power system analysis. Power system analysis. You will add this, so what you can do then is with this software, guys, you can do short circuit analysis, load flow, and coordination. We did short circuit, load flow, and coordination. Next project, we're going to be doing it for a 4,000 amp 48277 with transformer, so bigger system. Same thing. You got it now, you got it. You didn't get it now, you have one more shot. There's redemption here to redeem yourself. Though I would like each one of you guys to create their own for this project. As we move forward, guys, to make sure that everybody is doing their share, I'm going to introduce performance tests and all the software that we do to make sure that people are liable to what they're supposed to do. So that's going to be next project. I will take you guys to my office and I say, here's a project, run it for me, for everything that we do, to make sure that everybody knows, meet the expectation. Sign off on you. We need to make sure at least you know the bare minimum. Okay? Any question, guys, about the software?
Yeah,
Yes, sir.
my one-line print preview, it comes up with a blank sheet.
Are you here? Okay. Okay, let me look at it. I don't know. It doesn't show like what I'm showing you right now. Okay, let me look at it in a second here. Any comments, guys? Any questions? Any comments? Any questions? So, so that's basically what the coordination is. So we did short circuit, guys. We did coordination. I want you guys to do also the arc flash label. The arc flash label is very easy to print. If you go run arc flash label, the same thing that we did, okay it, and then you got to the labels here. When you get to the labels, here's all the labels. Now, can you guys see that after, let's go look at the arc flash. After you did the arc flash, let's go to the main. I went to the main. Can you guys see at the beginning, and anybody remember what they said at the main? They said you can't work on it. It's dangerous. Anybody knows why now you can work on it? We put circuit breakers and we adjusted it. We put circuit breakers, we adjusted them. Now it's actually level zero, that's as low as you can get, level 0, and you can work on this, and the arc flash is only 3 arc flash boundary is actually just 3 inches, arc flash boundary, okay? Very low. Now, Darren, if you remember, it was red, right? That's because there was no circuit breakers at all, no protection. no protection. Cool. Now these you guys want to print. So let's go to the lighting panel. Same thing. Look at the lighting panel. It's level 0. Level 0. That you need for level 0, guys. You need the gloves when you work on it, and not a whole lot of protection for PPE. Here's your receptacle panel. And do me a favor. You're going to preview these. You're going to hit print, 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 and export them into a PDF file. I should be able to export here. They come as an Excel. Do we go export to a PDF? Let me see if I can print to a PDF. Check print, continue. Here's what here's what it looks like, guys. Here's what it looks like when you print them. This is what you're going to give to your electricians. This is what you're going to give to your electricians. The only one that's dangerous to work on, can you guys see the only one that's dangerous to work on is what? The meter center. Remember that meter center, work on the energized, there is no circuit breaker ahead of it. Everything else, the red means you cannot work on these equipment energized. Big deal. Cool. And then you can hit print and print them colored. Darren, you and Andrew are going to be presenting on this project. That's part of your assignment. So I will take a snapshot at this, show it. And this is your first time doing short circuit, load flow, and arc flash analysis. So if somebody smart start asking you all these questions, guys, just say, well, this is our first shot at it, right? You're good up to, I would give what we did right now 80%. Higher than that is good. Any comments, any questions? Any comments, any questions? Okay. You got yourself an arc flash analysis. Okay, thank you guys. That's all we have.